Hey guys, welcome back. It's me, Mr. Lewis again. This is your 8.3 section video, Changes of State. This is the last video for chapter 8, talking about states of matter. So today we're going to talk about what exactly we're talking about when we say changes of state. On board your screen there, you see your bell ringer. Go ahead and stop me, pause me, go ahead and read it up. And then you know what to do. Answer it up there on edmodo.com. All right, let's go and get started. Here's our objectives today. We're going to see how energy, we're going to describe how energy is involved in changes of state. We're going to describe what happens during melting and freezing. We're going to compare evaporation and condensation. And we're also going to explain what happens, explain what happens during sublimation and identify the two changes that can happen when a substance loses or gains energy. All right, here we go. When we talk about changes of state, what we're talking about is that something is changing its physical form from one form to another. So changes of state is physical forms. In other words, it's a physical change. So in other words, we're going from, remember I told you there's five states of matter, but we're only worried about the first three, liquid, solid, and gas. That's the only three we're going to talk about. All right. So when things go from a liquid to a solid, that's a change of state. When they go from a solid to a gas, that's a change of state. When they go from a solid straight to a gas, that's a change of state. Those types of things, that's what we're talking about when we say change of state. Okay. Now, particles of substance move differently depending on the state of substance, and we've talked about that. We've talked about how in a gas, the particles will move willy-nilly and they bounce off each other and they've overcome their attraction. They're just moving fast. If they move really, really fast, it's going to be very hot. If they're moving slower, it's going to be cooler, that type of thing we've talked about. We said how the particles in liquids can slide past each other. That's the reason why they take the shape of the container that they're in. We talk about a solid, how solid particles are locked together in place and they just vibrate back and forth, but they cannot overcome the attraction of themselves, so they are still locked in place, but the particles themselves are still vibrating in place. Every particle of a substance moves differently depending on the state that it is in, whether it's a solid, liquid, or gas. And the particles move have different amounts of energy when the substance is in different states. And there's something else for us to remember as well. Okay, so let's take a look at this slide right here. Now, this slide right here, you're going to see it again a little bit later on, but let's take a look at this slide right here. It says the terms and arrows change the state. Water commonly goes through the change of state shown here. Now look, we already know that water can be a solid, it can be a liquid, it can be a gas, all three of those different things. We already know that. So let's talk about what exactly happens when water goes, this is water down here, all right, when water goes from this state and becomes a solid chunk of ice. Well, what ends up happening is it's actually going to lose energy right here as it is going to become, as the particles slow down that water, they slow down slow enough that they clump up together and they form this solid. They're actually losing energy. So this would be an example of what kind of reaction, endothermic or exothermic. All right, they're losing energy. They're not gaining energy. If they're losing energy, it is an example of an exothermic reaction. Over here, we have melting. All right, so from this solid, to go from the solid back to the liquid, it has to gain energy. And since it has to gain energy, then it is going to be an endothermic reaction right here. Okay, so right here, exothermic reaction, right here, endothermic reaction. Next, if that same liquid gets heated enough and starts to evaporate, what do you think has to happen? Well, it has to gain energy right here to go through the process of evaporation. And eventually those particles get up in that cloud and they slow down. Those water particles get up in the cloud and they slow down slow enough that they end up losing energy and falling back to Earth again. When they fall back to Earth again, they are actually losing energy, so that's an exothermic reaction. And again, down they fall back into the water right here. Okay, so let's talk about solid to a liquid. This is what's called melting. Melting is a change of state from a solid to a liquid. Temperature at which a solid changes to a liquid is its melting point. All right. Thing to remember: its melting point is the point at which it changes from a solid to a liquid. Okay, so when we're talking about this, the melting point is where that is. Now, keep that in mind. We're talking about melting point that's solid to a liquid. All right. So what happens to melt? We have to add energy, and since we have to add energy, that is an endothermic change because energy is gained by the substance as it changes state. Okay. So just like I said back here, I hope I said that back here on the last slide. When we are gaining energy, when we're adding energy, it is an endothermic reaction. Okay. So that is the first thing. The next thing we're talking about is freezing from liquid to a solid. Now, freezing is a change of state from a liquid to a solid, and that point at which that substance changes into that solid is called a freezing point. So, melting point changes the liquid into a solid into a liquid. Freezing point changes the liquid into a solid. All right. So when we remove energy, when we take energy away, that is an exothermic reaction. All right. So when we take energy away from something, that's an exothermic reaction. Now, the next thing will be evaporation. And evaporation changes state from a liquid to a gas. Now that's what happens when you put that boiling pot, you put that pot of water on that stove, you turn up the stove, and you start seeing gas particles come flying out of that, or you start seeing not condensation. You start seeing gas coming out of that liquid. Now that is evaporation. Interestingly, evaporation does not have to occur when that substance reaches its boiling point. All that has to happen is those particles inside that water has to be moving fast enough that they overcome their attraction and they turn into a gas. Boiling is the change from a liquid to a gas through the liquid. The temperature at which that liquid boils is known as its boiling point. Boiling, in order for something to boil, it has to reach that boiling point. So evaporation does not have to be at the boiling point, but for the water to boil, it has to be at that boiling point. So boiling occurs when the pressure on the inside of bubbles, the vapor pressure, equals the outside pressure on bubbles, the atmospheric pressure. That's when the boiling occurs. All right. Now, when we talk about this, let's look over here. So looking at our little diagram here, for boiling, in order for boiling to occur, we have to be at the boiling point. Okay, that's a big thing to remember. When we talk about evaporation, we do not have to be, notice that the temperature is right here. This is the boiling point. We do not have to be at the boiling point in order for us to start evaporating. As long as the particles at that surface have reached that point and not the entire substance itself, those particles will break away in evaporation. All right. Now, we talk about effects on pressure. Now, at the boiling point. Water boils at different temperatures depending on what altitude you are above sea level. Now, typically we say the boiling point of water is 100 degrees. Well, that is at sea level. But if you're in Denver, Colorado, which is a mile above sea level, the temperature at which the water is going to boil is a lot lower than what it is if it's at sea level. Okay, so like Phoenix, Arizona is pretty much sea level. If you're at sea level, you're going to boil at 100 degrees Celsius. But if you're in Denver, Colorado, it's going to boil probably about 97 degrees, somewhere right around there is when the water is going to boil. And the reason for that is because the atmospheric pressure at the higher levels causes us to have a lower boiling point on that water. So when we talk about boiling points, we're talking about it at sea level. Okay. Now, condensation. Condensation is simply changing a state from a gas to a liquid. All right. So when you're outside and on that nice hot day and you have that nice cup of lemonade or whatever, and you're looking at that lemonade and you got it out of the fridge and it starts to get wet on the outside, what's actually happening is the outside surface of that glass is cool enough that the water vapor that's in the air clumps on it and actually forms those water droplets. And here's a visual concept for you guys to see. So you guys can see that. Come on. A pointer, arrow, there we go. And I'll be quiet.
When a substance changes from a liquid to a gas, the process is called vaporization. A liquid must absorb energy for vaporization to occur. Evaporation occurs when some molecules at the surface of a liquid move fast enough to escape into the surrounding air as vapor. Evaporation can occur well below a substance's boiling point. When a liquid is heated to its boiling point, Molecules within the liquid absorb enough energy to form bubbles of gas within the liquid. When condensation occurs, a gas becomes a liquid. Condensation can be seen when water droplets form on the outside of a cold glass of lemonade. Water vapor molecules near the cold surface slow down enough to clump together on the glass, forming droplets.
All right. And there you go. That's what I was just telling you about condensation. Now there is another state that's called a sublimation, or another change. It's called sublimation. Sublimation is solid straight to a gas. Now what does that mean? Well, that simply means if you've ever seen dry ice is a chunk of liquid carbon dioxide or liquid nitrogen, something like that. But it's a chunk of it. And it has to stay at a certain temperature in order for it to stay in that chunk. As soon as it is exposed to a higher temperature, it goes straight from a solid into a gas. Now that's why if you see fog machines act in the same kind of way, although it's not going through sublimation. But in the movies and stuff, they use a lot of liquid dry ice. There you go. They use a lot of dry ice to make that fog look and stuff like that. Dry ice goes straight from a solid to a gas. Now, typically when we see a state change, it's typically from a solid to a liquid, then to a gas. But sublimation goes straight from a solid straight to a gas. All right. Now, change of temperature. Most substances lose their energy. One of two things happens to the substance. Its temperature changes or its state changes. All right. And here is something I want to talk to you guys about. Right over here. This is a graph showing this water. All right. It's showing the melting point of water and the boiling point of water. All right. One thing I want you guys to pay attention to. Notice that these are two different temperatures. The melting point, in other words, that point at which that solid is going to turn into a liquid, that melting point is going to be the same throughout. Now, it's hard to measure this, but until this entire block of ice turns into water, it will stay at the same temperature. It stay at 0 degrees. It will stay there until an entire block of water has changed into water, or entire block of ice has changed into water. Once it has changed, all right, then its temperature will increase. And as we keep adding energy to it, eventually we could get it to its boiling point. If we get that water to 100 degrees Celsius, we get that to its boiling point. Now the temperature of that water stays the same until all of that water is boiled away, until the whole substance of that water is boiling. All right, that is when we get to the boiling point. But notice right here, the boiling point and the melting point are not the same temperature. You guys need to pay attention on that. All right, melting point is when it changes from a solid to a liquid. Boiling point is when it goes from a liquid to a gas. All right. And it's review time. It's review time. It's time for the review. Remember, guys, you guys are going to have to do the notes yourself starting in the next video because it's chapter 9. I'll be quiet. Let you guys go ahead and do this real quick. All right. Well, you guys have a great day, and I'll be seeing you in the future.